things on their desktop is comfortable. Going to the extreme lengths of getting to a supercomputing center, going through the account kind of processes we have, and learning how to use all the system things detracts from their time. They have a schedule to keep, and they don't have weeks or months to learn how to do something different. They need to do something that's familiar. So we believe we can deliver a portal service, basically a web interface from our centers to a few key applications, predominantly commercial, though. In our software development side, we have a program called Create, which is working on some very specific tools. We tend to deliver those tools and some commercial applications through a portal app that allow them to run in our space. Our target to begin with is MATLAB, or a similar product. MATLAB's kind of expensive. Because it's pretty easy to see that many applications in that space with a very minor adjustment to the MATLAB code can run in parallel. And you can see speed-ups of 10 to 100 with almost no effort. So I think that's a big enough carrot, and it's a familiar enough environment that people already have to get them to start. So those are some of the things we've got coming down the road. And last, I'm back to why do we do all this? It's incredibly important. We have people in harm's way today. So we need to put the right kind of armors in place and look at how long rich history do we have. Whether from military commander, it's life or death. Can you get that airplane that shoot in theater at the right time to support a mission? Is it put the right load out on an aircraft for a mission or not? For the people who are accountants, it's huge dollars. You can change the path of the aircraft or the ships. Over time, you can save tens of millions of dollars every year. Big deals. In terms of like Air Force and things, we're on the cusp of a huge change in the way we can design things. We're about a year away from one of our great projects in terms of being able to actually virtually fly the aircraft in their those. So we can basically send control commands to the different control surfaces on the aircraft and virtually fly it and get the entire stresses and strains on that frame. It's about a year away. That's going to change when we do design. We have similar projects in ships and antennas. Just some of the big challenges. There's also thousands of little things. We support about 500 projects every year. Across Department of Defense, everything from very basic chemistry projects, for that comment earlier on chemistry. Chemistry is clearly our growing community. If there's any community that's grown substantially in the last 5 years, it's the chemistry community. Chemistry and materials are really the exploding field for us. In that area, to different types of direct energy kind of weapons, to the whole gamut of types of work. And last is it makes a huge difference. Like I said, in the area of armor, we've got about a 20-year history with Army folks designing, virtually designing them and actually getting kids out to the field to support different vehicles we've had in Iraq and Afghanistan. It makes a difference. So thank you all very much.
And part of today's program is actually interactive, so we've asked the speakers to leave 5 or so minutes at the end of their talks for some questions. We've got a microphone.
And does anyone have a question? I see some of our workforce education people in the background, and I was wondering, how do you go about integrating the civilian and military workforce in terms of training and keeping them current, like you said, and keeping them customer aware?
So our workforce, for the most part, in the computing center part of the program, our workforce is probably 80% contractor, 20% government. It's virtually all civil service. There's very few military, actually, in the operation of the centers. In the software development side of the house, it's a much more even mix. About half contractor, half government, some military. I'm not sure I quite get the gist of your question.
Well, it sounds like most of your workforce is civilian workforce.
It is.
So, okay. So you said you brought people in from the academy.
The ultimate customer we serve is the warfighter. It's Department of Defense. Our purpose is to fight and win wars. So the leadership of the Department of Defense are military officers, and we go to great lengths to make sure those new ones coming out of the academy are aware of what this technology does for them. There's actually some pretty impressive programs at both the Navy and Air Force academies focused on computational sciences. So they're getting a good grounding, and we're trying to promote that understanding with the work at the laboratories, interaction with the computer centers.
Anyone? You just step up to the microphone there.
What if you would be so kind to comment on Cray program for the audience people who are particularly interested where
Sure.
how you are investing in research trying to get much better scalability.
Right, so about 5 years ago, we looked across the space and decided that we had some issues with the number of scalable codes we had that was being developed in the future. So we started a program called Create. It's aimed at 3 different military high-need areas. One is design of military aircraft, one design of ships, and one design of antennas. Antennas seems kind of odd, but you look out, there's not a military system out there that doesn't have a gazillion antennas on it. So that, and we formulated teams around the country from wherever we could find people with the right talents to try to improve the functionality of different tools. I look at, in the aircraft one, there's 4 sub-projects. One deals with fixed-wing aircraft. I mentioned a little bit about, we're about a year away from being able to virtually fly designs. We have one in the helicopter space that's had a lot of press in the last few months because we can finally now actually resolve the vortices coming off the rotors all the way down to the fuselage of a helicopter. And that was a huge jump forward in terms of being able to predict performance on a helicopter. We have a new one called, it's really focused on early design in that space. We have similar things in the other projects to say, hey, let's take some very conceptual ideas and be able to kind of grow those in odd arrangements. Like in the aircraft spaces, can I do different gridding combinations and make the wings bigger or smaller, the tail bigger or smaller, into very conceptual phases up front, and understand what that might do to the design of the aircraft, or the ship, or the antenna. We have a Drive project in Cray as well. We call it MG. The actual name of the product itself is called Capstone. And that's a series of geometry and meshing routines, basically calls that any application could use to manipulate geometries. And that was derived because we looked at the actual problems our customers needed to solve and decided actually the long pole in the tent for them in terms of time to solution wasn't the amount of time it took to run the problem in the supercomputer. If I can get the 2-month run down to a week, great. But they still took them 3 months to set the problem up. And if I can't get the geometry and meshing down in a space where they can set the problem up within a few weeks or a few days, I haven't got their timeline down to a point where it's really effective for engineering design. So we are putting a lot of energy into those projects at this point, and we're beginning to deliver the first round of codes.
Got a question?
Sure.
Out of the several thousand petaflops, I think you indicated, is the peak performance of your total systems.
It was like 1.7 or something, yeah.
1.7 petaflops. What is the actual percentage of utilization of those nodes, and how important is that to you?
Okay. It's a great question. In all honesty, I pay much more attention to something I call expansion factor than utilization. Utilization generally runs on most systems between 70 and 90%. Okay? And I would be horrified if it started running 95%. Okay? Because it starts, the higher it gets to 100%, the less work that actually gets done. Just to go back to queuing theory, you have to have some slack in there to actually get work out. So there's a natural place in the hierarchy of machines, and it tends to run somewhere between 70 and 90. But I spend a lot more time looking at something we call expansion factor, which is a normalized way we use to look at basically wait time. How long does someone wait for their job to start relative to how long does it take to run? So if a job takes an hour to run, you have to wait an hour for it to start, it costs you 2 hours. That's kind of our expected measure. We kind of expect it to take twice as long if you get your answers as it takes to actually run. We generally are seeing today actually better than that. But to me, that's the more important measure. That's the measure of productivity. How much work are you actually getting done? And we focus on that.
Okay, let's thank our speaker again. We have a little gift for you for coming all this way to to join us, and thank you very much. And this is a 5-day stay at the Nittany Lion Inn, because you'll be snowed in for the rest of the week. So. I noticed in the part of the schedule that